Hi, you're welcome to Explore Insight. So, in my last video, I made mention on complement subtraction. So, we want to take a look at when we talk about binary subtraction. So, if you're just joining this video for the first time, do well to subscribe to this channel. So, without any further ado, let's get started. Now, we want to look at first complement subtraction, and I will take this with two examples so that you can properly understand this given topic. Now, in this first complement subtraction, we have case 1. In my next video, I'm going to do case 2. Now, in the case 1, we want to treat a subtraction that has to do with large number from small number. So I represented the small number as S and the large number as L. Remember, L will be the subtrahend and S will be the minor earned. Now, the next thing we need to do is to consider the rules, which are the steps to carry on when we want to implement this kind of task. So basically, we have 4 rules. The first one is to take first complement of the subtrahend. The second one is to add it to the minor earned. It means you're going to add the first complement of the subtrahend to the minor earned. And then the third, we have to consider a case, which is if carry is not generated, the result is said to be negative, and it is in its first complement form. Now, the fourth one is we're going to take the first complement again to get the actual result, which we are looking for any given question. Now, let's look at an example for you to understand and to apply these rules for this case 1. Now, for this, we are asked to subtract 12 from 3. So, mathematically, 12 minus 3, 3 minus 12 will give us 9, whereas 12 minus 3 will give us 9. So, don't mix them up. So, in this case, we are subtracting 12 from 3. So, now, let me rearrange it well. So, you can see here, 3 minus 12. 3 is a minor end, while 12 is a subtrahend. The next step I need to do is to convert 3 and 12 into binary form. So when I convert it into binary form, I'm going to show you a quick trick to that. I'll just spread out these values, which is 2 raised by 0, 2 raised by 1, 2 raised by 2, and 2 raised by 3, which tells us the binary bits. Now the next thing to do is to check, convert it. So we have 2 raised by 0 to be 1, 2 raised by 1 to be 2, 2 raised by 2 to be 4, 2 raised by 3 to be 8. To that, in 3, what can sum up to give us 3? It's going to be this and this, and whereas these values will be 0 0, so we have 1 1. Now for 12, we have these values to be turned on as 1, whereas this side will be 0 0. So with that, 3 is going to be 0 0 1 1, and our 12 is going to be 1 1 0 0. Literally, if we were to convert 3 to binary, it's just 1 1, but because of this value 12 is in 4 bits, we have to still put this 3 in 4 bits. So take note. Yeah, so the next thing we need to do in this step, which I've written here, which is the 4 steps we have to take for first complement subtraction. The first thing we need to do is to take the first complement of the subtrahend. Now, in this question, what is the subtrahend? The subtrahend is actually 12. Now, we will take the first complement, and the first complement of 12 is to inverse what we already have for 12. So, since 12 is 1 1 0 0, our first complement will be 0 0 1 1. This is why we have 0 0 1 1 here. Okay, so since the first step is to take the complement of 12, which is the subtrahend, our complement of 12 will be 0 0 1 1. Now, the second rule states that you need to add it to the minor earned. And what is that value? It's actually 3. This 3. So now we are going to add 3 to the first complement of 12. Now let's recall our 3 is 0 0 1 1, and our first complement of 12 is 0 0 1 1. Now if we add that up, we're going to have 1 plus 1 will be 0 with a carry of 1. 1 plus 1 plus 1 will be 1 with a carry of 1. Then at this point we'll have 0 0 plus 1, which is the carry. We'll have 1 here. And this part will have nothing, which is just 0. Now to that, we want to consider the step 3. Now in step 3, do we have a carry? It means, do we have any value we carried over? No. Take note, our carry is being represented by these blue colors, and that's what I've actually done in virtually all my videos, so you can know the difference. Now since carry is not generated during the last digit operator, now this like digits we did not have any carry, then we'll perform first complement to get the actual result. Now remember, when the carry is not generated, by default it's going to be negative, so this is why this value will be minus 0, 1, 1, 0. The next thing to do is to apply our first complement, and our first complement is just to take the opposite bits of what has been given to us. Now for this value we have 0, 1, 1, so our first complement will be 1, 0, 0, 1. And if we convert that to base 10, we're going to have -9. So I hope you'll be able to grab a knowledge from this video. So do well to subscribe, share, and like this video. And don't forget to watch my previous videos and look out for my subsequent videos. Do have a nice time. Thanks for watching. Bye.